Hello and welcome. I'm Bill Wake. We're here working on a basic interpreter. We've done a fair bit of work. We've got a bunch of statements working and all the expressions, including functions and subscripts and all that. But we've decided to add a new feature, which is one that kind of started showing up in the 70s, I think. Basic itself was from the 60s. And what it is a way to put multiple statements on one line. Now, in BASIC, usually it's, line 10, line 20, line 30. You want to change places, you go to 30 and stuff like that. But now many statements can execute within one line, but it gets complicated because for loops have to bounce back to, formerly they could bounce back to a line number, but now they can't. They've got to bounce back to a spot in the line. Same thing with, there's some things around if then and then GOSUB. GOSUB goes to a subroutine at a certain line number and returns. And if it has to return to the middle of a line, we need a way to represent that. And we've come up with this notion of location, which is the line number and an index position in the line to tell us where to go. But I think we've done something, in the small, I think we've got a fatal flaw. I think the scheme we've been using overall can work. We just had to adjust it. Just have to. Okay, so an example of this multi-line thing here, line 10, x equals 1, y equals 2, then if c, then print x, and the whole rest of the line is part of the if c. So if c, then print x, and then if w, then print y and print z, okay? And if you drew this out in the tree form it parses into, it looks something like this. There's a leaf node for x equals 1 and y equals 2. Then there's a kind of compound node for if c then, and then it's got two slots for print x and if w then, and it has two slots for print y and print z. Now, due to the way the colon works and the sort of parsing, this if statement is kind of the only one that really brings in nesting, okay? And it basically the tree, if there is a tree, there doesn't have to be, we could have stopped at x equals 1, y equals 2, but if there's an if statement, it's always the last thing in the line because the text after the if statement is all part of that if statement, okay, because that's just the way if is. And so we have these trees that are kind of like leaf, 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 tree, and the tree contains leaf, 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 tree, containing leaf, 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 tree, until somebody at that last level has to be leaf, 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 it has to be all leaves. And the scheme we have, okay, basically we treat it as if it divided up at the colons and made a zone for each, okay? And so we number each of those sections. So the first section till the first colon is 0, then y equals 2 is 1. Then if c, then print x is 2. Now we're not reflecting the tree structure at this point. We're just reflecting the kind of linear structure. All right. And then slot 3 is if w, then print y, and then print z. In our indexing, when you go ask what's the statement at an index, 0 returns x equals 1, 1 returns y equals 2, 2 just returns print x. We don't actually return the if statement as a whole. And that's what I would call a fatal flaw. Okay. We need it, we need to refer to both the if and the first child in different situations. To interpret the second slot, we need to find out if C is true and only then decide whether to print X and do the rest of the line. Okay. So having one index for both things is not going to work. So instead what I want to do is number the if and the child separately and its first child. Okay. So even though they're both, the if and the first child are both in that same colon delimited section, they're two separate nodes. So 0, 1 are the same. Node 2 is the if c, and then 3 is print x, 4 is if w, another if, 5 print y, 6 print z. So there are only 1, 2, 3, 4, 5 colon delimited sections, but now there are 7 sections when you add the print nodes, the if nodes, sorry. All right, and so what this looks like, and it kind of makes sense when you see it as in the tree form, it's almost like the node number in the thing, 0, 1, 2, 2 corresponds to the if statement, and not the first child, because we care about the if statement. So it's right there numbered at that level of the tree, and then we kind of continue numbering linearly down. And the interesting thing in this structure that's leaves with a possible tree at the end, containing leaves and possible trees at the end, that actually ends up being a linear structure. I mean, it sounds like it's a kind of tree, and it is a kind of tree, but we can number them in a row. We don't need hierarchical numbering or anything like that. Don't need outline numbering or something. Okay, so the idea, we're going to number the nodes, not the colon sections. All right, now that's not what we're doing today, right? We're numbering them based on those sections, and I thought it was a pretty good. We did a little spike to see, like, hey, can you number? Does it make sense to number these this way? And it made sense. It's consistent. It's just not useful to us the way it is. All right. I ran tests just a second ago, or a few minutes ago before we started. And let's see our to-do. Look at how if statements. All right, I'm going to change our goal. Our goal is account for both if and its first child. All right. We don't need that. Let's go to, I guess it's parser tests is where we ended up putting this. Okay, so the count changes now. In this one, we were just counting the leaves, basically. Go to 1, 2, 3, 4, 5, those 5 children. But now we want to count the if statement too. So this should be 1, 2, 3, 4, 5, 6, 7. So let's adjust that. And then I think we're going to get the statement numbering correct. And then there may be something blowing up in the interpreter. We will see. All right. Now this is going to fail because it just passed a moment ago with 5. All right, 5 is not equal to 7. Good. And here's count. Well, basically we have the if, and we subtracted 1 because making sure we were, stopping before the if. Now we're going to add 1 to it if there's an if, and so +1 and -1 cancel out for us. Oh, this is so nice. Doesn't it feel better already? Statements.count plus, it's kind of the parent count plus the count of the inner child. Okay. I think that's going to make it work. Let's go back and run that. Okay, I love getting that -1 out of there. That's encouraging. Okay. The at one, that's going to be a little trickier. Parser tests. Okay. So let's build this up a little bit. Let inner if equal, and let's pull this piece out. Is that far enough? Okay, make sure this still, whoops, cannot infer, well, it's a statement. Okay, we can format this a little better, I think. Okay, so the inner if is GOSUB 3, GOSUB 4, and then the outer if, also a type statement, is this one. don't know if I can get these on the same line. Okay, so if number 0, the numbers don't matter, but the children here do. Okay, so again, let's make sure this runs. Okay, so it's much more visually apparent to me that this thing has 3 children. Okay, and 0, 1, 2. Well, we would like. Well, let's keep it as it is for now. 0, 1, 2. 2 should really now be the if. Okay, so this should be outer if. Okay, and then at 3, 0, 1, 2, 3 should be GOSUB. GOSUB 2. All right, and then 4 should be inner if. And if we want to get to its children, five and 6, they're GOSUB 3 and 4. Okay. I will probably renumber these after we've got it working. I want them to be kind of in order and make it apparent that 5 goes to 5. Okay, but this should fail, right? We just changed a bunch of stuff. Okay, make sure it's right first. GOSUB 0, GOSUB 1, outer if. That's all that. GOSUB 2, inner if, GOSUB 3, GOSUB 4. Okay. This should fail. Okay. Good. I mean, we've definitely changed things. Okay, so we'll stop this. And this one's a little more complicated, I think. Okay. So if the index is greater than list.count plus 1. So the problem is in the case where we have the index equal the last thing in the list, that's list.count minus 1. If it's equal to that, we really should return list of index because 0, 1, 2, remember 2 was the if. We want to return that if. Okay, so I think this greater than becomes greater than or equal becomes greater than or equal becomes greater. So if it's in the entries in the count of the list, then just return the entry. Okay, so if it's less than the count, yeah, so the opposite of greater is less than or equal to count minus 1. Okay, we can work on the logic in a minute. All right, but if the index is greater than list.count minus 1, in other words, if it's count, I guess if it's greater than or equal to count minus 1, it's if it's greater than count minus 1, the only thing greater than that, first thing greater than that is list.count. So if that's the same as greater than or equal to list.count. Okay. All right. And then if the node, so if the last node is an if, okay, the only one that has recursive statements, we'll ignore the condition and just get the inner if. All right, and then we're going to take the inner. feel like we're losing a +1 here or something. We need to. Well, I don't know. Maybe we can just let it tell us. Pretty sure that's the case. Yeah. Okay. All right. So if we got our case, we got 0, 1, 2. That was the top level. And if we ask for 3, go back to our test. If we ask for slot 3, we're after that first child of the outer if. Okay. And that should be 0, right? So index minus list.count. I'm pretty sure our +1 goes away. All right, let's run the test. Okay. Now, I think we can be simpler if I flip the logic, but I want to be careful. Okay, so if the index is greater than or equal to count, okay. Sorry, too many messages to make me. Okay. All right. So if the list is if the list is less than the count, the index is less than the count. I'm gonna flip this. Okay. So this one is if index less than list.count, right? Because if it's not greater than or equal, it must be less than. All right. Those are independent conditions. I can swap them. Okay. Now, well, we know we're covering everything. Oh, no, we're not, because what if index is greater than or equal to list.count, but the last node is not an if? Well, that can't happen. Okay. If the last node was a leaf, 0, 1, 2 got us a leaf, that was the last node. We returned it here. There's no index past that. Okay, so in this case, if the index is less than the list.count, we just return it. If it's greater than or equal to list.count, that's kind of the else here. Okay, that's the opposite. We now know that the last node is an if. Okay, and that's a by construction thing. I don't know if we want to. Well, let's. Oh, it won't compile without that. Let's return an error, and the error is I think it's saying the error is a parse error. Okay. The error is this is really and let's see. It's statement.add index too big. Okay. Can't happen. Shouldn't happen. Well, maybe internal error. Okay. Okay, let's make sure this is still good. Build failed. Oh yeah, I did forget that. Oopsie. All tests should pass. Well, oh, we had multiple cases. Okay. This should be 1, 2, 3, 4 now. Yep. Okay. All right. And then let me do the renumbering. So 0, 1, what was 2 is now 3. What was 3 is now 5 and 6. Okay. Adjust location to count nodes as well as its children. Okay, well, that was easier than I expected. All right. Now, in our interpreter, I'm still not happy with all this. Okay, so if next line number is nil, that means we haven't done a GOTO or anything like that. Okay, if the location part plus 1 is less than the statement's count, location equals location plus 1. Yeah, this is the part I think is wrong. I think we need to look at the count method we added in parse here. It's actually in statement. This statement count is telling us, and that we tried that before, but I think I think this is wrong. I don't think it's going to matter to us count of parse.statements. Okay, so the parse.statements.count is the literal count. Like in our example, it'd be 0, 1, 2. There was 3 entries in that sample line number here. Okay, so this would be 0, 1, 2. That would be the statements.count, but we could end up trying to jump back to this if statement or something in line here. So we should allow things beyond here. Okay, so imagine if this were GOSUB 100 instead of print X. When we want to come back here, we need to resume execution here at the if W, not anything related to slot 2. It's in the middle of the whole thing. Okay. All right. Now this may blow up. Okay. If we can move forward by parts, let's move forward by parts. Otherwise, if we're, I guess if we're past that, right? Yeah, if our location.part plus 1 is equal to the count, and then it means we're trying to get an index too high, and we've run out of parts on the line, so we need to go to the line after the current line. All right, and then if the next line number is not null, which it might be from that, then we do basically a GOTO. We force the location to that next line number and reset it to nil, so people default to going to the following line. All right, and then if there was a line change, we got to go get the line and parse it, okay, and then execute it. All right, and we still have somebody calling steps, so we couldn't get rid of that just yet. All right, I think this is correct, more correct anyway. Where it may fall apart, I think the if statement is not prepared to deal with multi-part lines. So there may be a test on those lines, but let's see what the impact is. Right, what test is this? It's an if test, okay. All right, well, maybe this is telling us if needs some work. It's certainly true that if needs some work, so okay. Do if, output expression, and the statements, okay. So we're going to evaluate the condition. Right. Okay, well, maybe I should see what the index out of range is. Where's our... Let's see here. Okay, so let's print location. Line 25, part 1. Part 0, part 1. Okay. That's... Okay. At the level, the whole line, there's only one slot at that top level. It's got an if statement in it, so it has no leaves before the if. All right, and then slot 1 is the print 30. We're trying to execute the next piece. Okay. Statement sub. Well, I don't think this is sub. This should be our at. Okay. Where's our at? Statement index. Okay. Parse.statements, and the index is location.part. And the output. Okay. Let's try this test with that. What I'm afraid will happen, okay, yeah, that's what, okay, interesting. So what, we're basically not falling out correctly, I guess. What I was worried about was if it's false, then will it know to skip the rest of the line? And I think that's messed up too. But let's see. So if it did 25, 30, 25, 30, 50, I almost wonder if it did, I don't know. let's stop. Let's go ahead and trace it. I don't know. Okay, so we're in the first level run. Let's go look at the statements. Location 25, part 0. I guess the parse statements, it has one value. It's an if. It has a number, and then it has an array of two values, two prints. Okay. So our index is 0, 1, and 2. All right. And then let's look at parse.statements, location.part. Okay. That's the whole statement. That's a good thing. I think we've already gone too far. Let's print output. Yeah, so we executed the if. Oh. No, we did increment. Okay. All right, so we executed the if, the 2530. We've come back around. Let's parse.statements. I get so confused. Yeah, I think we're going to have to do some adjusting. Where's the line number? Next line number is nil. Line number is 25. That seems wrong to me. Oh. It's like this did not increment. So I would have expected part to have incremented and now first be 1 and then 2 and now be 3. But I don't think it is. Oh, maybe we're okay. (25) part 1. Well, I think that's what the if should be doing, but why is it 2530? Okay, let me go back. Sorry, interpreter. The if again. Yeah, I think this is wrong. So we shouldn't need to try step. We should just set the location up so that the next statement is there. And if it's not, if the condition fails, we should be going to the next line. which sure sounds a lot like what we're doing at the top of that loop, doesn't it? All right. So if the number is not 0, then I think return. I don't think we change anything. I think we just want to increment. Okay, so I think we want to do this. Location equals location current line number and location dot part plus 1. Okay, so if the condition passes, that's the location. Otherwise, well, I think we can do this kind of. I'm gonna cheat. All right, let's put like max int. What is it called? Int dot max int dot well let me do this. Okay, I'm forcing it to the last point of this line number. It's definitely going to be greater than, we can't fit that many parts in a line, so we'll clean this up, but I want to try and get through the test. Okay. I could use a int max or something, whatever. There's a constant, I'm sure, but I'm more curious to see if we can just get it working right. Okay, let's clean that and let it run. Okay, one failure. Okay, what do we get? 3050 is not equal to 25 3050. Interesting. So it didn't execute the 25. Right. Because our interpreter does that at the top up here. When it comes back around, it increments. Okay, so I think the if is even simpler. If that happens, don't do anything. You're just going to kind of fall through to the next part. If it is 0, then we want to go to the next line. So we're kind of forcing a fake part number. All right, let's try again. Okay, now let's run them all. There's probably more ifs that have a similar problem. No? Okay. All right, so now we can reverse this and simplify it. Okay. Maybe I can find int max. Okay. All right, so there's int max is not. Oh, okay. There's got to be a constant for this, right? Oh, it is just dot max. Okay, I was afraid that was a max function. Okay. Right. Okay. So if the condition is false, then go to the next line in effect. Otherwise, fall through the next part. Okay. Let's say use new location with if statement. Simplify it to just default to going to next part or next line if the condition fails. All right, and let's just take a look around these if tests and make sure we're happy. If with false, falls through. Okay, should print 3050, yes. 1. Then it sets the part to 1, which is bigger and just falls through, but it already wanted to go to. So next line number gets set here, so it doesn't increment that part. Okay. Now I think what I'd like to add is this case: if with multiple statements and failing condition. Right. So if the condition fails, it shouldn't do either one of these prints, right? We should just get 50. And we need to make sure that false. Bump bump. Arithmetic overload. Oh, +1. Oh. Oh, can I make that? Can I flip that? If location.part +1 is less than count, subtract 1. I think I tried to do this yesterday and wasn't successful. Okay, if location.part +1 is less than count, I guess it's if location part 1, if location.part less than equal count less than count -1. Oh, that would be one way around it. Subtract 1 from both sides. Okay. Yeah. In a way, I want to do this. Maybe I should just do that. Because then I come in with next line number, not nil, and I go to it. That's more explicit in the if, so maybe that's better. Oops. All right, and we have a go-to for that. I don't know why I put these above. Where's do go to? Yeah. Finding the right place for these. If okay, so in effect, I'm doing a go-to of that. Okay, I guess I've been cutting these spaces out. Whoops. Okay, so I think that kind of makes more clear, makes it more clear. If the condition fails, jump to the next line. Otherwise, we're just falling through the next part. All right, I think that should all pass. Did I already run it? Tsuki, hey, nice to see you here. So we're developing a basic interpreter in Swift. Let's see, a little less not using a Mac, okay? You got a Mac for the first time? Okay, so let's check this in. We made if work with multiple statements on a line. Waiting for the M2s. Yeah, I don't blame you. They sound like monsters. Somebody had one of the, I don't know, one of the big expensive towers, and like the M2 laptop just eats it up. Like, oh well. Maybe Paul Hudson, maybe. Okay, so I think our if statements, let's see how we're doing on our to-dos. Adjust numbering to count for if in the first child. We did that. June 17th. Huh. Yeah, it's certainly, I mean, I'm sure you've used its imitators, so, got some muscle memory there, but yeah, they're nice. I've liked having them. It's mostly been my main machine. Okay, how if statements. Okay, so let's change the wording on this. It's more like make sure if statements work with multiple statements in a line. Yeah. course, that's the thing when you get to, like, I don't know, I use IntelliJ sometimes, and you end up with, Control Option Command L does something, Okay, for next on same line. I think GOSUB might be easier. Okay, so the issue is this one. So x equals 1 GOSUB 3000 print x. When we come back from the GOSUB, we should print x. Okay, so let's see. Find GOSUB. Oh yeah, it kind of stinks if you have to have different keystrokes in different apps to do the same thing. Yeah. Okay, so let's do one GOSUB returning inside line. Oh, I don't think I've used GNOME. Okay, so our program is going to be GOSUB 100 print 10. We'll just do an end here. Hmm. 100 print 100 and 110 return. All right, and if things are going right, well, actually, maybe another print would be a good. Yeah, at one point they were talking about making it more like iPad and just kind of like each window, each major thing its own app, and you could flip between them. Okay, let's see. So our GOSUB, we're going to go to 100. It should print 100. Then it should come back, print 10, and then fall through the next line, print 20, and stop. Okay, so we expect 100, 10, 20, and stop. Expecting a string. Oh, left that an N. Okay, 120 is not equal to 110.20. Okay, so it didn't pick up the moving to the second part. And I think that's our return addresses. Oh yeah, let's go up to our stack. For loop stack, return stack. We only track line numbers. We don't track locations. Okay, so, all right. Well, thanks for stopping in. Return stack. So, because we only track line numbers, when we say return, we're returned to the following statement because it's like line number plus 1. All right. So let's find GOSUB. Find GOSUB. And do GOSUB. All right, so yeah, here's program.line after line number. And because normally we just return to the line after the GOSUB. No, we're not. Okay, so let's fix our stack first. So the stack should be ready to handle locations. And somebody should complain. Yeah. Cannot load this. Okay. So the GOSUB, well, we don't want the line after. We want the location after. So we want a location, which is location.line number and location.part plus 1. Right, so go to the next sub piece. If that's too big, if there is no next sub piece, it'll detect that in our top loop and wrap around. Okay, now how about this one? Go to return target. Return cannot convert value of location to expected argument type line number. Should our go to default? Well, I think maybe it should take a location. I think we can add one. Is that going to help things? Not really. Okay. Well. Again, we got to go to our loop at the top. Our run. Okay, so if we come up here, next line number is nil, location.part. Basically, we're going to try and increment. So I think that means the GOSUB should just push I think it should just push location. Okay. It's kind of like, when does it get incremented? Well, if we go to the next thing, if we come back to location, we would naturally fall back to the thing. Okay, so I think that may work better. And then my question is, this one probably needs to take we should just probably do location. No. All right. Well, let's see. Run that test again. I guess I'm looking forward to the for next and like, how's that going to work? Okay, what do we do? 120 is not equal to 110.20. So it did not return where we wanted it to. All right, so I guess, where's the GOSUB? We push the location on the stack. We go to the subroutine line number. We do a return. We pop the target and we do a go to the target. This maybe should be like go to next. Or go to after. Okay. Let's break here. Well, let's break here too. We can see what's on the stack. Okay, so let's run this. Okay, so let's see what location is. Line 10, part 0, that was the GOSUB. All right, we push that on the stack. We go to line 100. Eventually we return. So we'll continue. Okay, step over there. Let's look at the return target. We're hoping it's line 10, part 1. Well, it's going to be line 10, part 0. What am I typing here? Return target. Line 10, part 0. Okay. Do go to after. Okay. Step. Location. Line 10, part 0. Okay. Step. Let's step out. Well, that didn't work. Okay. What had happened? Go to after. Well, I expected to get back to my run loop. Let me run again. Okay. The return target par blast. Okay, so step over that. Okay, so we did the return. Oh. Okay. Turn output. Okay. Let's print the output. It should just be 100 so far. 42. Am I on the right test? Where I messed up somewhere. Big surprise. Okay, let's step over that. Go to after we trust. Okay, so location should be 10-0. I put 100, yes, okay. Next. Okay. 100. We should go around the loop again. Not done. Print next line number. Nil, good. Print location should be 10-0. Okay. Lunk. What's location dot part? Okay. I'm worried the wrong statement is sitting in there right now. Line parse line number return. So we didn't really get to we didn't really change line numbers. All right, so we do have to change next line number, I guess. But it's going to hard code this 0 in there. Ugh. Okay. I think we're due for a break. Let's take a break. This thing about the GOTO is a little more complicated than I thought. Maybe next line number needs to be it needs to have its part number too. All right, but we'll see. Anyway, let's take about 3 minutes and we'll come back and get this thing straightened out. Hey, welcome back. All right. So I think maybe that's the issue that the GOTO Yeah, I think we can make our GOTO be specific here. Okay. Line number. Let's see. I don't know where we are though. Let's see. Here's GOTO, new line number. Okay, so let's provide a do GOTO. I kind of want to keep this case separate, so let's make a GOTO that takes a location and it's going to say next line number equals new location. And this one is always 0. Okay. And then next line number, we're going to change to a location. All right. Will it build? No. this. Okay, well then in that case it was a new line number. It should be a 0. Next line number equals target. Target of int. Yes, that's also a 0. That's if condition then 25, meaning go to 25. Okay. Still got one messed up. Oh, cannot convert. Yeah, this should just be next line number. Okay. It's not nil, so it's safe to unwrap. All right, now let's see where we are. Oh. Location is an interpreter. We'll take our breakpoints out. One failure, GOSUB inside line. Okay, I think that's progress. We've made next line number handle it. So let's go back to that. Go to after. Go to after is really only called here. Okay. And I think we do need to do the +1 thing. Now, so we're saying when you get the return value, we're going to go to it. So location is location dot line number location dot part +1. All right, and then go to after just becomes do go to return stack. Okay, nobody's calling this now. That, okay, and yeah, that should be better. Two failures. Okay, GOSUB. GOSUB 100 print 52. Statement index too big. That sort of means we didn't parse the line? I don't know. Our internal one worked. That was good, but all right, let's see that. Okay. We'll we'll break on this as well. All right, break here again. Run this test. Okay, so print location, line 10, part 0. So we should be pushing 10, part 1. Let's step over. We'll just print return stack. 10, part 1. Okay. And then break here again. Continue till we get to the return. Okay. And step over. Return state target should be 10 part 1. Okay. And we're going to go to return target. Step. Okay, well, we're returning output. Okay, we're back at the top of the loop. Let's print the output so far. It's just 100. 42. Oh, is that our test? Oh, the subroutine prints a 42. Okay. So let's see, next line number should be 10 part 1, right? Okay. So step over. Next line number is not nil. Okay. Oh. So we need the mechanism up top again. Ugh. All right. I think what we want is I think I want a function that says I'll give you a location. You tell me the real location. Is that going to do it? So if you give me 1099, I say, oh, you want line 20, the next line. If I give you 10.0 and there's a 10.1, I'll give you 10.1 back. If there's 10.1 but not 10.2, next time after that you get line 20 again. Okay, so let's it's kind of extracting this. Okay. So we want this kind of stuff. Okay, if the next line number is nil and there's a room for it, then return that location. If next line number, wait, We just want to look at the location, I think. Okay, else. Well, maybe this is this quite right? Is this next? I'm not sure what I'm after here. Okay, can I use that in here? That's the real question. Next line number equals nil. I don't know. I'm stacking too many things up or something. I'm getting lost. All right. Is this function useful? So it's saying you give me a location. I'll give you either the next location in the field or the location of the next line number. That sounds interesting. I mean, sounds useful. Okay. So if somebody has not specified a location, then that would seem to give me the location I want. Now this next line number thing, okay, if it's not nil, sorry, if it equals nil, let's see if I use this function, what happens. Okay, if the next line number is nil, meaning we didn't do a GOTO, then I want to equals nil. I want to change location. I'm worrying about the parsing. And this. Okay. Can I do it? Okay. If the next line number is nil, I really want to. I want to call this. Equals, I guess that's let. next location for location. Okay, so I want to update my current location. Now, the problem is, okay, if I haven't specified a new location, I think I want this to be next location. All right, so if I haven't specified the next location, I just want to skip forward one step, okay? And I'm gonna set that to the next next location to that, okay? Now I've got to check. Okay, I think this stuff goes away. Oh, next line number is the real name. Well, it's a little bit of a misnomer. Okay. So, however I get in here at this point, next line number is no longer nil. It either was set already or I've fallen through to the next location. So this always happens. Location equals next line number. Yes. Okay, but I don't want to do that first. I think I want to let's move this up. Okay. So at this point, this would be next line number. Whoops. Next line number, right? Because we would have assigned it here. I don't know, do I have to put the exclamation? I never quite know. Apparently. I thought it was smart and it would realize like, hey, it's not nil, so it must be assigned. Okay. Line. Okay, so I'm taking that from here. Okay. So if the next line number doesn't work, I want to know about it. All right. Then this part. Okay. I get the line. I want to avoid reparsing if I've already got this line. Okay. Maybe that's not my biggest problem. If I reparse it, okay, let's let that go for now, the reparsing bit. Okay, we'll continue. Continue. Still a problem. Okay, what are we getting? 42 error, statement too big. Oof. 42 was fine. We returned. Okay. Hang. Bumped something random. Okay. All right. Statement too big. Let's check that GOTO GOSUB stuff. Okay, GOSUB. Well, this is location dot next location, right? Or next location for location. Okay. and go to the subroutine. That part works. Return stack.pop. Go to that target. This type is location. Good. All right. Next line number equals new location. New location is where we said to go to return to. Okay, so next line number equals new location. Now go back in our main loop. Okay, next line number is set. So we should fall through here, find the line, adjust the location, and parse it. I'm going to take this out because at this point, next line number is always not nil. Where's the brace? Let's make sure. Okay, I can revert if I have to, so I'm just going to clean out these, and hopefully seeing it all together will make it make sense. Okay. Okay. If the next line number is nil, that should be the default fall through case. Then we're going to say, no, it should become the new location. All right. Then we're going to look up the new location, make sure it's a valid line, set location. So from now on, we treat that as the line number and parse it. Okay. And this still fails. Okay, so let's step over. Okay. All right, so we should have a next line number. 10-15-0. That seems plausible. Okay. Step over. Okay, next line number is not nil. Okay, we look for line 15. Let's look at line. Should be a print. Okay. Next line number equals nil. Okay. Let's see the parse. Line 15, print 52. Sounds perfectly good. Step 1, statement.add parts. Okay. Print location. 15-0. Statement.add. Parse.statements. Okay, so let's see the statement. Print 52. Okay, and that's line 15, right? All right. And let's see the output. Ah. Output 42, which is what the subroutine printed. Okay. I lost my place. Let's just do a step over. Should take us to the print. Okay. All right. Value 52. Okay. Let's skip forward. Result is 4252. Okay. Let's step out. Over. Okay. Next line number is nil. Okay, the location is 15-0. Or 252. Okay, let's step over. Line 20, part 0. That seems right. Okay. Parse end. Okay. Let's step over. Done should be true now. Yes. Step over. And continue. Okay. I don't know if that ran right or not. Continue. Okay. Oof. Okay. Well, this next line number thing is bugging me, so I think I want to change the name. Next location. Okay. Run all tests. All right. What else? Well, let's look at where we are. This parse. See, I really only have to parse the line. Actually, I only have to get the line if it's changed. Okay, so we can do something there. All right, let's go subreturn in the middle of the line. Let's deal with parse only if line changes. Reparse maybe is a way to say it. Okay, interpreter. All right, so I'm kind of okay. Now let's find GOSUB. do GOSUB. Append the next location. So that's very normal return address stuff, right? You take your program counter, you increment it 1, and you say that's the place I'm going to go when I get back. And then you go to the target of your GOSUB, which is good. On return, you check for an empty stack, pop it, and return, do a GOTO to the target you have. I mean, you probably have an instruction that does this in a real computer, but that's okay. We're simulating it. All right, that all seems perfectly okay. Do GOTO. Now, who calls this? Find selected symbol. Okay. Well, I don't need that one. I think that should really be location, new line 0. Well, and I can make location do the work there. If you create a new location and you don't specify a part, it's just 0. That seems normal. Okay, so do GOTO. New line number, all right. Do GOTO subroutine line number. That's okay. Do GOTO subroutine line number. Well, let's check in. This is more refactoring than anything at this point. Okay, so C, GOSUB can return to middle of line. All right, now this one, I would think he'd be better off taking a location. Line number. Let's make it a location here as well. Location supply number. Okay, now GOSUB is going to take a location. Rename that to subroutine location. Okay, so we save the current location, the place following the current location, jump to the subroutine location. Okay. I was looking for more of these. Do GOTO new line number, do GOTO program.line after. If that seems fair. You definitely go to the line after the current one with the if. So the increment wouldn't work, but let's make this a location. Okay. Next line number. Find next. Okay, let's make this location. No. Yeah, I'm gonna bubble this too. Okay, first we'll get rid of them, then we'll see. What is this? The next. Okay, let's make this a location. location. So I'm pushing everybody to hold locations. Now I don't think anybody's using this. We know for next is messed up going for line numbers, but we'll deal with it. Okay, now there's if go to. Let's see, this one. If the condition is not 0, target. Let's find the caller. Well, let's make a location out of this. Pushing it back as far as I can. Now we go here. This is a location. And this doesn't need to say it anymore. Okay. All right, so we've eliminate or move references to line number to refer to location instead. Head. Okay. Good. All right, where's that leaves? GOSUB returns to middle of line. Yes. How about GOSUB can return to middle of line? All right. And this reparse. Okay, we've done those two. Reparse only if line changes. All right. This is going to be invisible to callers. It's an optimization in effect, but I think it's the right thing to do. Parse. Okay, run. Step 1. Oh, and sorry, let's see who calls this. Nobody. Slight detour here. And rename this one. Back to step. All right, now the parse. Okay, so I think I'm going to move this down. Parse doesn't reference location or next location. Okay. If okay, location is the current location still. And the invariant is the line for the current location is loaded first. Is always loaded. Okay, so location's about to change. Okay, but we also know next location. All right, so I think this is the case. If location dot line number is not next location dot line number, that means we're moving. And I think this should happen. Okay, so if we've changed lines from this we know next location is not nil at this point because we just set it, or it came in set. Okay, so if the location line number and the next location line number are different, that means our parse is going to be invalid. Okay, so let's load up the new line number and parse it. And then reset location to next location and next location to nil. And now we've restored our invariant that the parsed line is the same as the location line. All right. And I'm going to flip the order on this. I don't know. Just sounds better to me. Its new location is not the same as the old location, then change. All right. Hopefully everybody loves this. And that kind of restores the flow we originally had, because we only would load lines if we didn't, or we would not reload lines if we did an increment. Okay, but we had to make sure they got loaded on the return statement. Okay, but I think now we've kind of identified the invariant and restored it, so that's good. All right, commit that. Reparse lines only if the line has changed. Okay, now all right, to do reparse only if line changes. Okay. For statement returning to middle of line. All right. Let's take a couple minute break and we'll come back and start tackling this. I don't know. Maybe it can be done in the half hour we have left, but we shall see. All right. So 2 or 3 minutes. All right. Welcome back. Okay. May have a little disturbance here. Alrighty. So the for loop. We had a test for next.
I'm sorry, honey.
Let's see if that exists.
It'll only be a few minutes downstairs, honey.
Okay. This should fail because we haven't addressed this thing yet.
Where's Mama? Oh, okay. You want to come down? Okay. 5 minutes, B.
Okay, so this one we have the for and the next on the same line, but basically it scans forward trying to find the next statement. It doesn't think to scan inside its own line, and so it gets to the end of the file and can't figure out where the next statement is. Sorry. Okay, let's see. So we have I guess we want to find the for statement. Where's that? Out of order, huh? Okay. variable. All right, for variable, initial expression, final, and step. All right, we evaluate those things. The body is line after location, so that's not right. Okay. The body in this case should be in the same line, so it's more, whoops, it's more our next next statement after thing or whatever that was. All right, then the next one, append the variable and the body line number. So that's what it returns to. That's a problem. And then we got to find the next. Well, this is the one it was failing. Oh, here we go. To do should find next anywhere in line. All right. Parse program current line. Next equals parse statements dot first. Right. I think, well, let's see. The thing is, I don't want to have a case where I have next I or next I, and then the for statement. All right. So we really need to start at the current line. I think the problem is this is good at so this is good at articulating all the lines, but we want to articulate all the statements going forward. And I don't know, I mean, the one I don't know if it's legal, let's make up a weird case. For I equals 1 to 10, I guess this is legal. Print I, next I. Okay, so if, assuming we want to make this legal, we really do have to skim from the current statement, print X. Okay, so we would want to start from the colon, scan the rest of this line, and every statement to the end of the file. Okay.
Let's go play. You want to play? Should we take that upstairs?
So
Okay, here we go.
current line less than program line number. Yeah, well, that's that part's true.
Let's go play, Mom. She's upstairs.
So maybe what we want to do is
I'm coming. Yep, I'm coming. Okay. No, we're not going to play in the stairs. You got to turn around and go upstairs right away.
boy. It's like I want to list all the lines after my current line, and then within those, I want to list all the statements within those lines. And I don't think you can say like a conditional and then a next. You really have to be fair about it, right? You only get one shot. And it's really the textually next one, so it's kind of let's see. So current line.
Can you put the crumb in the trash?
Oh gosh, I don't know. I gotta. What do we do with this next? I guess we just go to it, and then it pops and goes back. Okay. 4 pushes this with the target. We go to the next. We find the next. We go to it, and then the next pops the stack, evaluates the expression, and otherwise goes back to the body. Okay, so well, current line is really, we really want to start at location, next location. What's current line? It's a line number, right? Okay, let's transform this to work with locations first. I think that will help. And we're still working by line. We're just talking about locations. This is current line dot line number. We're returning an int, which is the location of the next statement. So we really want to return the, what are we doing with it? Line number. Yeah, we really want to return a location. Where is the next? And so it's already a location, so we don't need to convert it. That's a step forward. All right. If the variable is that, then return current line. Otherwise, basically move on to the next line. Line after current line dot line number. Okay, this should fail one test. Good. All right, let's take the credit for what we got. Let's do this. It's not credit really, right? It's just let's lock in the progress we have. So make finding the next statement work with locations rather than line numbers. Okay. Should find next anywhere in line. All right, so I guess what that means is the next, I think parse.statements is really the right thing to look at. We don't need to look, we've got that mechanism to look inside and find the ifs and the tail of the ifs and all that we did. That's really finding the location of the next statements, but the next statement needs to be a top level statement. It shouldn't be an if. Even if, yeah, it just don't do that. The only way it'd be legal or valid would be like if it was if true, then next I. You know, it doesn't seem fair to say sometimes return it and sometimes don't. And I don't know, but we're making this restriction. We're saying next must be a top level statement. Doesn't have to be the first thing in the line, but it's got to be in the line. Okay, so we are not yet handling if it's in the same line as the original one. Okay, maybe we handle that first. let's see. All right, so we got parse.statements. Parse.statements dot drop first. Location dot part. Okay, so if our for statement is that's where location is. So the for statement, if it's print x for I equals 1 to 10, the for statement is in part 1, and we want to drop. Well, we'd have to drop +1. Okay, if it was first in the line, we would drop the first 1. Okay, so now here, well, let's make a copy. Let current statements equal parse.statements. Okay. All right. And what we want to ask then is if contains next for the variable then we want to return well, it's the location, it's the current location, it's the no, I'm not doing this right. Okay, let's see. We've dropped the first few, and I want to say, what's the index? I don't know. Is it a find? Current statements dot find first where? First index where? Okay. Let index equal current statement dot first index where something. Okay. And the something is something like this. Okay. If index is not nil, meaning we found something, all right, then we want to return the location line, the same line number dot part. That's the current index plus index. I think maybe part +1 plus index actually. So if the first thing in the line, okay, we're in the for line. If the first thing in the line is the for, then location dot part is 0, and index is 0 because we dropped one entry, so we got to get the +1 back. Okay, I guess that's, we got to get back what we dropped. Okay. Right, and then the where, and I'm going to be ugly. Well, I kind of want to do this. Okay. If the variable, if the item we're comparing to, which is a current statement, is of the form next variable, and the variable is the actual variable is the one we're looking for, then yes, we found the right next statement. Otherwise, well, what is this thing? Let's look at it again. First index where predicate throws returns bool. Okay, so if it's not the right one, we'll just return false. Okay. Golly. Well, maybe this is okay. If drop first doesn't do it in place, if it's returning something, I think it must be okay. Okay, it returns us a slice. So it doesn't modify it in place. All right, I think that's okay. Okay, so if it's next I print x, next I print I next, sorry, for I print next. Okay, we come in here, the current line, the location. Well, no, that's not right. I don't care about current line. I care about the parse in the location. Okay. Current line, not referenced, not referenced. Index bang. Okay. This can go down here. Okay. We're going to take the current list of statements, drop 1 if it starts with 4. If 4 is the second, we'll drop 2. Okay. We'll drop up to the 4. Then we're going to take the current index where the item we're looking at, if it's a next with the right variable, then we'll return true. Otherwise, false. Okay, if we do find something, that means we found it on this line and we're good. We'll return that location. Okay, let's see if that works. All right. Good. We clearly have some refactoring to do. It's not impossible. Well, let's make that next test. Okay. Oh, shoot. Didn't run it. Okay. Statement index too big. Did I do statement.add? Let's see if this makes a difference. No. Index is 2. Okay, well that's good. Interpreter test 0, 1, 2. Okay, return location, line number, location. Is 3. My +1 is not helping, is it? Okay, I got location 2, which is correct. I don't know why I convinced myself +1. Let's see if that's all it is. Location at part. We were at part 0. We skipped over that. Now we're at 0, 1. Why is index 2? Statements, 3 values. For I equals 1 to 2, step 1. For print and next. Okay, print statements 2. Next I. Okay, let's continue. $20 is not equal. Okay. I think we're onto the other problem. Our for loop is pushing line after, which is too late. Okay, so I believe the find next is okay for this one. All right. Let's put the test in, test for and next on different line with multiple parts. Okay, so in this case, I'm going to take this. Well, actually, I think even this will demonstrate it. For I equals 1 to 2, print I next I. It has to find it in the middle of the line. All right, and that, I believe, will fail. That one works. Oh, where's my... Okay, good. I don't think it should work. All right, found 4 without next. Yeah, we didn't find it because it wasn't the first. In the loop, we're looking at statements dot first. Okay, and then I think we just noticed the to-do here. to-do body could be in middle of line. All right. So I think we'll stop there, kind of in the middle of the for thing, but I think we've identified what's going on, and we've got some refactoring to do, like this chunk. Well, let me put this back. Is this one's failing? Yeah. No, I'll leave that for now. We'll clean it up at some point. But this chunk here, it really is the same as this chunk here should be. And we'll get by. All right, so we'll pick up there next time. I'm pretty sure we'll make the for loop work. It feels like we're closing in here. I think we've identified the two things that were barriers. All right. Thanks for joining me today. So next time is, I believe, going to be Monday. There's some chance Monday may mess up, but Monday or Tuesday, failing that, at 10 a.m. Eastern to 12:30 p.m. or 3 to 5:30 p.m. UTC. And thanks for joining me today. I hope you all have a good weekend, and I'll catch you in the future. Bye-bye.